we're good to start. So yeah, welcome to workshop number 4. Today's topic is remainders and fractions. And so for the layout, we'll first start out by cross multiplying and then just a variety of like multiplying mixed number tricks that'll be handy on tests. We'll then go to our second subtopic, which is remainders, and then we'll have a practice number test game.
Okay, so how would you normally find which fraction is greater? So we have 7th, 9th, and 8, 11. So for most people, they would try and make the fractions have the same denominators. However, there's a much easier way to find which fraction is greater, and it's called cross multiplying. So for the first step, you're going to want to multiply the numerator of the first fraction by the denominator of the second fraction. And then you're going to want to multiply the numerator of the second fraction by the denominator of the first fraction. And then you're going to compare the two products. And the larger number is the product of the numerator of the larger fraction and the denominator of the smaller fraction. So if you see here you're going to the numerator of first fraction, which is the 7, by the denominator of the second fraction, this 11. Then the numerator of the second fraction, this 8, by the denominator of the first fraction, this 9. You're going to compare the two. So 77 and 72. And 77 is the larger number. So this 77 is the product of the numerator of the larger fraction. So that numerator was 7. So that means this 7th 9th was greater than 8 11. So now this is an example for you guys to try.
Yeah, just go ahead and type the symbol in the chat.
Yep, the 7th is greater.
Okay, so now think about how you would attempt to multiply these two numbers. So a whole number, 5, times the mixed number, 6 3/4. So first you look at the distribution. Instead of the numbers, we have variables in place. So a times b, c over d. You would multiply the integer and fraction separately, and this simplifies the problem. So for example, a times b c over d, you would multiply a and b separately and a and c over d separately and add the products. For example, 5 times 3 over 3/4, you would multiply 5 and 3 and then 5 and 3/4. And 5 times 3 is 15. 5 times 3/4 is 15 over 4. And you would add those together and you get your answer is 18 3/4. And then the next one is 3 times 4 over, or 3 times 4 and 4/6. So you would multiply the 3 and the 4 and the 3 and the 2/3, because 4/6 can be simplified into 2/3. And then that would be 12 and 2, and you add those together. Wait, what?
Oh yeah, I think that was supposed to be the you try one, but we forgot to add transitions to it. So that's our bad. But if you guys have any questions on this topic, let us know.
And I think the final answer is supposed to be 14, not 18.
Okay, yeah, that might have been a mistake then. Okay, so this one's another topic. This one's probably the hardest of them all. So it's like a mixed number times a mixed number, and usually I guess people would just be to convert them both into improper fractions and then just multiply top by top and bottom by bottom. That could get really hard, especially when you're facing big numbers. So there's a pretty good trick to that too. Okay, yeah, so the concept is similar to the last one. It involves distribution. So imagine, so this is just one of the models, so t, just one mixed number times another mixed number. And so if you look at the right side, if you look at the last line where you see tv, so that's the whole number times the whole number, plus, so just take it as separate. So there are basically three parts to it. There's this first part where you multiply the whole number by the whole number. There's a second part where you add the t, where you basically add the whole number, so t plus b, multiplied by whatever the fraction is, so a over b. And then so that's the second part. And then the third part is just to multiply the fractions by each other. So that's a times b, or a times a, and b times b, or you can just do a over b squared. And it'll make more sense in like the practice problem next. Yeah, so this is one of the practice problems. So using the last formula, you would first just multiply the whole numbers together. So that's 3 times 2. And then for the second part, you would need to add the whole numbers. So that's 3 plus 2, which is 5, times the fraction, which is 4/5. And so 5 times 4/5 is just 4. And now you have two parts, so that's 6 plus 4. And then the last part, you just squared the fraction or multiply it by itself again. So that's 4 squared over 20, or over 5 squared, which is 16 over 25. And then you can just combine the sums to get 10 for 6 plus 4, and then just combine the fraction to it to get 10 and then 16/25. Okay, there's one special case with these numbers, and if you notice on this one, the fractions actually add up to 1. So like 1/3 plus 2/3 is 1. So yeah, it's the same, like the integers are the same, but the fractions add up to 1. And so with this, you sort of want to apply the same method. So yeah, so t plus v, like from the model, so that's 9 times 9. And then you want to do the second part, which is just the fraction, which is just 9 times 1/3 plus 9 times 2/3. And once you add that up, you get 9 times 1/3, which is just 3, and then 9 times 2/3, which is 6. And then 3 plus 6 is just 9. And so that was the second part. And then the third part, you just multiply the fractions together. And so this time you won't square it since they're different fractions. So you would just do 1 times 2, which is 2, and then 3 times 3, which is 9. So that's 2/9. And then and so it's written like 9 squared plus 9 plus 2/9. But you could also write it as 9. You could also like distribute the 9 out to get 9 times 9 plus 1 to get, and then plus 2/9 with the fraction. And then you can just add the 9 plus 1 inside the parentheses to get 10 times the 9 to get 90, and then just add on the fraction next to it. So that's 90 and 2/9 as your answer. And so there's a pattern to this one. So whenever you see two mixed numbers that have the fractions add up to 1, you can basically just rewrite it in this format right here. So you would just have the whole number 4 times the whole number plus 1, or 4 of 4 plus 1. And then that's basically the first and second part combined in a way. And then for your third part, you would just need to multiply the fractions by each other. So that's 2 times 3, which is 6, over 5 squared, which is 25. So that's plus 6/25. And then you would just do the same as last time by solving in the parentheses to get 5. times 4, which is 20, and then just combine the two. So basically so you see like the whole part can be written as n of n plus 1. So if this was 3, then it would just be 3 of 3 plus 1, and that applies with any whole number.
Okay, so how do you solve for a remainder? Well, you usually just divide out the answer and then see what the answer is, and the remainder is just the leftover numbers. So here, let's just try normally solving these.
Yeah, so just type the remainder in the chat for all of them, and just normally.
For the first one, well, in the former slide it was 58. Here it says 59. So for the first one, the remainder should be 1. And then for the second one, the remainder should be 0. For the third one, the remainder should be 1. And then for the last one, the remainder should also be 1.
So when looking at the remainders for these numbers, there's a pattern, and see if you can notice what it is. So if you don't remember, the rule is to add all the digits in a number and then divide it by the sum of 3 to see if the number is divisible by 3. You can go to the next slide, by the way. So if you look at the previous problems, if you add the number that you're dividing, so 59, or not, 5 plus 9 is 14, and 14 isn't divisible by 3. So if you remember the previous problem, that had a remainder. But for 90, it didn't have any remainders because it is divisible by 3, because 9 plus 0 is 9, which is divisible by 3. And 175 and 34, if you add the digits, they're not divisible by 3 either, so they each had a remainder. So basically doing what I just explained, you can divide each of these numbers by 3 to see if they have a remainder and what answer you get. Okay, yeah, those answers are correct. So for the first one, 14 divided by 3, it'd be 4 with a remainder of 2. 9 divided by 3 is 3 with a remainder of 0. 13 divided by 3 is 4 with a remainder of 1. And 7 divided by 3 is 2 with a remainder of 1.
Yeah, so notice that whenever you guys use the first method, which is just like normally dividing by 3, and then whenever you use the new method of just adding the digits and then dividing it by 3, you get the same answers. And so for these examples, the numbers were pretty small, so you could have easily done either method, but on tests they like to give you a lot of like 3-digit, maybe even 4-digit numbers, which can be pretty hard to just like normally divide by 3. So that's why we suggest just getting in the habit of just like adding the sum of whatever you're dividing. So that's like if it's 145, just add the sum of 1, 4, and 5, and then divide it by 3, and then whatever the remainder of that is, that's the remainder of the actual number. Okay. Yeah, so go ahead and try these problems. These are the ones they typically like to give you on tests. Yeah, Jessica, yeah. Yeah, you both got it right. So, yeah, so yeah, 0, 0, 2, and 2. So you just add those digits up and then divide by 3, and it makes it much easier. Okay, so now we're just going to play our practice test game, but before we do that, for remainders, there's really a trick for any number. So like 4, 8, 7, 13, 11, there's a lot of tricks. So we would recommend just like Googling up and, you can Google them up, watch YouTube videos or whatever. But yeah, there's basically a trick for every number, and so yeah, we highly recommend just like researching up on those. And then so now we'll play our practice test game. And so for those that may not know, this is where I'll be sharing like a practice test, an actual number sense practice test, and usually we would have 2 teams and they would go against each other, but since it's just 3 today, we can just y'all will all be on the same team, and y'all will take the same practice test and basically like work together to find the answers. And so yeah, I will and yeah, I'm gonna share the screen, and then and there's also a document, and I'll basically give that document